to record the session. Do you see my screen?
Yes.
So if you don't have any questions, I'm going to begin the next unit, which is exponential functions. Okay, so remember, we are going to have test. Can you write the test tomorrow?
It says online class too.
Okay.
She was searching for the Zoom.
Ah.
Where are my glasses? Okay. See ya. I was blind. Do you want to move the test to tomorrow?
It would be better, no?
Huh?
Because I'm going to begin the new unit.
No.
No, anyway, so yes, so we can have the test on Tuesday, but today I will begin the new unit. Okay, so remember, Tuesday you have the test. So unit 1 test. So now I want to begin unit 2, which is about exponential and logarithm. So exponential and logarithm are basically inverse of each other. So what I mean by exponential functions. So a function is exponential. Let's say a is a positive number. So f of x equal to a to the power x is called the exponential function. For example, if a equals to 2, so you get f of x equal to 2 to the power x. So what is the y-intercept? F of 0 equal to 2 to the power 0 is 1. This is the y-intercept. Also, what is the behavior of this function as x goes to plus infinity or negative infinity? So the limit of 2 to the power x as x goes to positive infinity is obviously infinity, because 2 to the power of some big number is again another big number. And the limit of 2 to the power x when x goes to negative infinity is 0. Do you know why this is the case? When x goes to negative infinity, 2 to the power negative infinity is 0. The reason is 2 to the power, and like, for example, negative 100 is equal to 1 over 2 to the power 100. 1 over 2 to the power 100 is close to 0. So it's not equal to 0, but it's a very small number close to 0. So that means the limit of 2 to the x goes to negative infinity is 0. So that means the graph of 2 to the power x, the graph for 2 to the power x, remember the y-intercept was 1. So the graph of 2 to the power x is something like this. And the y-intercept is 1. This is 2 to the power x. But what about 1/2 to the power x, if f of x is 1/2 to the power x? So the behavior is kind of reverse, opposite of 2 to the power x. For positive x, so again, f of 0 is 1. So for both of them, the y-intercept is 1. But if you have positive exponent here, like f of 3, for example, is 1 over 8. F of 10 is 1 over 1024, and so forth. So you see, for positive numbers, when x is a big number, then f of x approaches to 0. So that means limit of 1/2 to the power x when x goes to infinity is 0. And the limit of 1/2 to the power minus x when x approaches minus infinity is infinity. Because 1/2 to the power minus x goes to minus infinity, is basically 1/2 to power minus infinity. So 1/2, let me write it here, why this is the case. So 1/2 to the power minus infinity is equal to 2 to the power plus infinity. Remember, when you have a negative exponent, you flip the fraction. So that means this is infinity. So now the graph of 1/2 to the power x, you can see that it's this guy. But the y-intercept remains the same. So it's 1, 0, 1. So in general, if a is a positive number, then a to the power x for a positive, for a greater than 1, a to the power x is somehow similar to the 2 to the power x. But the interesting thing is that for all of them, the y-intercept is 1, 0, 1. And for a less than 1, so for number between 0 and 1, the graph looks like this. If a is less than 1. It's not defined for a negative number. Exponential, the base must be positive. Now, what is the domain of the exponential function? Can you tell from the graph, or what are the possible values? Is there any restriction on x? No restriction. So the domain is all real numbers. So for f of x equal to, no matter a is less than 1 or greater than 1, for f of x is a to the power x. But the only thing we have to be careful is that a is positive. So the domain, there is no restriction on x. So the domain of f is all real numbers. The set of all real numbers. Now, what about the range? So range, remember, range is the set of y values. So look at the graph of f, a to the power x. No matter a is positive, a is less than 1 or greater than. So let's look at a greater than 1, but they're both the same in terms of range. So what are the y values here? What is the range of the y values? Y. Yeah, it's positive values. Y bigger than 0. So the y values, you see, I can show you on the graph, the y values are all positive numbers. So you don't have any y value below the x-axis. So all y values are above the x-axis. So that means the range of a to the power x, so the range of this function right here, so the range of f is the set of positive. So it's, I can say there are two ways. In set notation, we can say the set of real numbers, or maybe it's better to write y because we use y for range or the value. The set of y, so that y positive. This is the set notation. Or maybe better, sorry. More precisely, y in R, y positive. Or I can use the interval notation, which is the 0 to infinity base. Another thing about a to the power x is y equal to 0. You see y equal to 0 is the horizontal asymptote. Y equal to 0. So y equal to 0 is the horizontal asymptote. So I'm going to write it here again. So y is 0 is the horizontal asymptote. Now, what if instead of like a to the power x, I have something like f of x? Let's try to draw the graph and identify horizontal asymptote, f of x equal to, and also the range. Let me go to the next page. So I want to look at f of x equal to 2 to the power x minus 1 or x plus 1 minus 2 minus 3. So now what is the horizontal asymptote now? 2 to the power x plus 1 minus 3. y equal to -3. That's right. If you want to draw the graph, you remember the transformation in grade 11? So you begin with 2 to the power x, and then you have a horizontal translation from 2 to the power x to 2 to the power x plus 1. So let me tell you in steps. So you have first 2 to the power x, right? This is the parent, 2 to the power x. Now, if I want to draw 2 to the power x plus 1, I have to do a horizontal translation to the right or left? To the left, because it's x plus 1. So a horizontal translation to the left. So it's something like this. Very sharp. So this, then the red one is y equal to 2 to the power x plus 1. So I just move the original function 1 unit to the left. Now you have 2 to the power x minus 3. So you have to do a vertical translation downward 3 units. So I use a purple. Now this line is y equal to minus 3. So do a horizontal translation to the right graph, the red graph, 3 units downward. So it's something like this. So now this is y equal to 2 to the power x plus 1 minus 3. So the horizontal asymptote is y equal to minus 3. Another reason why this is the horizontal asymptote is because the limit of 2 to the power x plus 1 minus 3, when x goes to minus infinity, look, 2 to the power minus infinity is 0. So it's 2 to the power minus infinity minus 3. So this is equal to 0 minus 3, which is just minus 3. So this is another reason why the horizontal asymptote is y equal to -3. And remember, so this clear? The graph. Now, what is the range? So look at the y values. What is the range? Greater than -3. So you see, this is the green line. I just show you, these are the y values for the purple graph, right? If you look at the purple graph, I mean this, the y values are bigger than 3. So that means the range of this function is the interval from -3 to infinity, or in set notation is the set of y in R so that y is bigger than -3. Okay, so you should be able to draw the different graphs. And remember that if you multiply a graph by negative, then you have to do a vertical reflection around the x-axis. So you see here is 2 to the power x plus 1 minus 3. What you get when you multiply it by negative 1? So can you, based on this, can you draw the graph of y equal to negative 2 to the power x plus 1 minus 3, which is basically y equal to minus 2 to the power x plus 1 plus 3. So let's try to draw the graph of this. It's a reflection around the x-axis. So let me first draw the original graph. So the original was like this. So this is y equal to negative 3. And y equal to 2 to the power x plus 1 minus 3. Okay. Now, once you multiply it by a negative sign, you have to do a reflection around the x-axis. This is y-axis, x-axis. A reflection around the x-axis. I used another color like blue. You see? So I want to do a reflection around the x-axis. So it goes like this. So the blue one is now y equal to minus 2 to the power x plus 1 plus 3. So here. Do you see the reflection? Do you know the meaning of reflection? Actually, the term, the word reflection. What it means? No, the word reflection, the meaning of reflection. It has different name, meaning. What is the meaning of reflection? English meaning of reflection. The picture of something in a mirror. Reversed image, exactly. But it also means thinking. Thinking or thinking deeply or something. Anyway, so it's reflection. So it's like the reverse image around the x-axis. Okay. So you should be able to draw the graph of different types of exponential functions. Now, what is the relation between exponential and logarithm? So this is basically what I want to write is the fundamental idea of this relation between exponential and logarithm. So exponential and logarithm are inverse of each other. What I mean by the inverse, you see. So on one chart, I have x and 2 to the power x. On the other chart, I'm going to introduce you another function, which is log x with base 2. So we just saw that, like, if x is 0, 2 to the power x is just 1. If x is 1, 2 to the power x is 2. If x is 2, 2 to the power x is 4. If x is minus 3, 2 to the power x is 1 over 8, and so on. Now, if you switch, like, these two columns, x with y, you get logarithm. So, for example, logarithm of 1 is 0. Logarithm of 2 with base 2 is 1. Logarithm of 4 with base 2 is 2. Logarithm of 1 over 8 is minus 3. So you basically switch x and y roles from exponential to logarithm. So in general, so here I'm just talking about logarithm with base 2, because we can have logarithm with different bases. So, but here is base 2. So in general, we say that logarithm of b with base 2 equal to a if and only if and only if so when I put if with double F, it means if and only if 2 to the power a equals to b. So remember, in the logarithm of b is equal to a. If 2 to the power a, it goes like this. 2 to the power a is b. For example, as I just said, what is the logarithm of 8? Or what is the logarithm of 4 with base 2? It's 2, because 2 to the power 2, you see, 2 to the power 2 is 4. Now, what is the logarithm of? Logarithm of 1 is always equal to what? 0, because 2 to the power 0 is 1, right? What is logarithm of 8? 3. What is logarithm of 1 over 32? Negative 5. And so on. Okay. So that means if you want to solve, so this is the relation between logarithm and exponential. Now, how is the graph of the logarithm? So this is you have a new function. F of x equal to logarithm of x with base 2. So remember, f of x equal to 2 to the power x. It's something like this, no? So for logarithm, we basically exchange x with y's. So for 2 to the power x, the domain is all numbers, but the range is positive numbers. Now for logarithm, the domain is positive number, but the range is all real numbers. So you exchange x and y. So I'm going to draw the graph, but I explain why this is the case. So logarithm of x, the graph looks like this. So the domain is just positive numbers. The domain of f is the set of real numbers such that x is positive, or in the interval notation is the set n 0 to infinity. But the range is all, you see the y values, you see from this picture, the y values are just all real numbers. So the range of f is just the whole thing. That means from minus infinity to infinity. Now here you have a vertical asymptote. So that means the limit of log x when x goes to 0 plus. So 0 plus means goes to 0 from the right-hand side. So x is bigger than 0, but approaches 0 from the right-hand side. So this is negative infinity. So why this is the case? Just remember that 2 to the power minus infinity is 0, right? So that means log of 0 plus is minus infinity. Okay. So the limit of x log when x goes to 0 plus is minus infinity. Therefore, x equal to 0 is a vertical asymptote. And you see here the vertical asymptote, x equal to 0. Because x equal to 0 is the y-axis, right? X equal to 0 is the y-axis. So you see it's a vertical asymptote. So if you have different bases, so you can have, instead of log x with base 2, you can have different bases, like log x with base 3, 5. They're all the same. If the base is bigger than 1, they're all the same. Now let me tell you some important rules for logarithm. So this rules actually doesn't depend on the base. No matter what base is, so log of like a plus log of b equal to log of a times b. Log of a minus log of b equal to log of a divided by b. If you multiply something, or let's say log of a to the power r is equal to r times log a. In particular, when r is -1, this is a special case of 3, basically, but I just write it anyway. So log of 1 over a is equal to minus. Because 1 over a is a to the power minus 1. Right? So why so these are very helpful, in particular when you want to solve logarithmic equations. These are helpful in particular when you want to solve very simple equation. Log of x with base 3 equal to, I don't know, 4. What is the answer? What is x? This is a simple equation. But let's begin with this. 3 to the power 4. So x is 3 to the power 4 is 81. Now imagine that instead of this, you have like log x with base 3 plus log x minus 1 with base 3 equal to 1. Now, how you solve this one? You need to use the logarithmic, one of the rules, basically the addition of 2 logarithms. Can you solve this? So if you add them, so you basically multiply x with x minus 1. So now this is basically the same as saying that x times x minus 1 is equal to 3 to the power 1, which is 3. So you have to solve this x squared minus x equal to 3, which is a quadratic. But I leave it to you. Can you solve this and tell me what is the answer? It's good because there is just a one tricky point here. What is the please solve this. X times x minus 1 equal to 3. What is it? What is x? What is x?
1 plus square root 30 divided by 2. Otherwise, 1 ios root 30 divided by 2.
Okay, so you got the 2 answers. There is a square root involved in the answer. But here there is a point. You see, in this formula, x must be positive for the first logarithm to make sense. You see, because you have log x. What is the domain of x? Positive numbers. How about log x minus 1? What is the domain of log x minus 1? So let me write here. Remember that domain of, if you have f of x equal to log x, the domain is just positive numbers. If you have f of x equal to log x minus 1, the domain, what is this domain? Domain of this graph. Okay, what is the domain of this new one? No, log of x minus 1. X larger than 1, because x minus 1 must be positive. That means x must be larger than 1. So the domain of x here is from 1 to infinity. So that means in your equation, you have to be careful. X must be both in this domain and also in this domain. But the intersection of these two is just the second one, 1 and infinity. So when you find the answers, when you solve this equation, so x squared minus x minus 3 equal to 0. So you get x equal to 1 plus minus square root of 13 divided by 2. So you have x equal to 1 plus the square root of 13 divided by 2. 1 minus square root of 13. So the second one is not acceptable because this is less than 1. This guy is not acceptable, is not in the domain. So you have to be careful when you solve a logarithmic equation. Okay, so another problem, typical problem, is what if you have a logarithm of, so I can give you some logarithmic function like f of x equal to log of x squared minus 3x plus 2, for example. And I want you to find the domain. This is another typical problem. So in order to find the domain, how you can find the domain of this guy?
Is x squared minus 3x plus 2 at the top? Or
Yes, on the top. So find the domain of f. So what is the restriction on the logarithm? So remember, whenever you have logarithm, the restriction is whatever is inside the logarithm must be positive. So here the restriction is x squared minus 3x plus 2 must be positive. So from this equation, now we can find the domain. So x squared minus 3x plus 2 is what? Exactly, must be positive. So that means either, remember the chart, so here is negative, positive, positive. So the solutions are basically either in this region or this region. So the solutions are basically x either greater than 2 or x less than 1. So the domain of f, you can say, is the set of real numbers such that x less than 1 or x greater than 2. This is the set notation. In terms of the intervals, it's just minus infinity to 1 union with 2 with infinity. Okay. Now, I give you some exercise. base is 2. So the second one, it maybe is a little bit tricky, but try to do. Do you have any question so far? Logarithm exponential? Okay, so tomorrow I'm going to continue this discussion, but for now, I want you to finish your assignments, the written assignments, and you have to submit it by tomorrow, by 10:30,
Am I gonna be here at 10:30?
by 11.
Okay.
Okay,
Sorry.
so just give me a second. Do you have any question, Miss Ron?
No.
Okay, so you can stay. I'm here. If you have any question, you can ask me.